This lesson is going to be about chemical and physical changes, and the learning target is to be able to identify a chemical and a physical change and be able to understand the differences between those. So we know what a physical property is. We know that it's a characteristic of matter that you can observe or measure without changing the identity of the matter. We can tell whether something conducts electricity without changing the identity of it. We can tell whether or not something is soluble without changing its identity. We can tell what its density is without changing it. Those are all physical properties that we've gone over. A difference between that and a chemical property is that chemical properties describe how matter interacts with other types of matter, and they have to be observed uh, while they're changing into a different substance. So we can't just observe these chemical properties on a substance without changing it. And so that's a huge difference between chemical and physical property, and knowing the difference between those two is what we're trying to do here. And so when we talk about physical changes and chemical changes, they kind of fall right in line with the descriptions of chemical and physical property. We have physical changes are changes to samples in which some properties of the material might change, but the identity of the matter does not. So this could be something where we are smashing that thing. We're changing its mass and its volume. We're changing its shape. But we're not changing what that thing is, whether it's gold, whether it's we dissolve salt in water. We're changing some of its properties, but we're not changing what it is. It's still salt dissolved in that water. As opposed to a chemical change where this is where the substance is actually changing into something completely different that has new physical and chemical properties. We're going to give some examples here, but just remember that the big difference between these is chemical change, something new is formed and there's new physical and chemical properties. In a physical change, that thing retains its identity. It's still whatever it started off as. And so an example of a physical change would be if we take water um, and we boil it, right? When I take water and I boil it, I'm making water vapor. I still have water. It looks much different when it's coming out of here as steam, but it is still water coming out of there. If I put it through a condenser and condense it back into a liquid form, it would come back as water. And so it didn't fundamentally change what it was. Same thing with ice. If I freeze water, I'm making ice, but if I melt that ice, I'm turning it right back into water. It didn't change what it was. It didn't turn into, I don't know, gold when I froze it, or it didn't turn into carbon dioxide when I evaporated it from here. It stayed exactly the same identity. It just changed its form. And the difference between a physical change and a chemical change is that when we have a chemical change, we're getting fundamentally different substances coming out of that. We have new substances that are formed. And so if we have a tree that's burning, we start with a living, breathing tree. And as that combustion happens, we get things that are completely different, like water and carbon dioxide that are given off by combustion. They are completely new substances and they have completely new chemical and physical properties from what that tree, the substances making up that tree, had before things started burning. So they are completely different. We can't just condense them back into a living, breathing tree. It's not going to work that way. They're completely changed. We would have to go through a chemical process in order to get them back um, as a tree. And so that's a chemical change, and that's how different they are from each other. And so when we're looking for signs of a chemical change, there's certain things that we can look for that would give us a hint as to whether or not there's a chemical change happening. If we see bubbles forming, if we see energy changes where there's maybe energy given off or things start to get colder, that could be a sign of a chemical change. We could have an odor change. There might be a new gas given off that we're smelling now. We could have a color change. For example, if we see rusting happening, we could have a formation of a solid. Sometimes when you mix two chemicals together, a solid forms. And so that's a new substance, a new solid that's formed, and that would be a sign of a chemical change. A couple of things to note with these is you're going to want to write these down to make sure you have these, is that these in themselves are not specifically like, yes, there's absolutely a chemical change happening. The only proof of a chemical change is a new substance. And so when we talk about bubbles, this one can be a little bit tricky because when we boil water, you guys know how that works. If we boil water, we're going to have bubbles, but these bubbles need to be a new gas. So we might have to do some sort of a test on the new gas that's formed to make sure that it actually is a new substance. With an energy change, when we take water and we cool it down and turn it into ice, there's an energy change happening there, but we are causing that energy change. This type of energy change, whether it's getting hot or whether it's getting cold, would be something that's given off um, by the process itself of changing, right? There's not energy coming in or going out. This energy is actually being given off by the chemical process. So this would be something like an explosion where all of a sudden we put in just a little bit of energy, we get a huge amount of energy out. There's an energy change happening there. This odor change, that one's pretty self-explanatory. Like I said, you could have a new gas that's formed, a new substance that's being given off. That would be a really sure sign of a chemical change. We could have a color change. Again, this would be something that would be happening kind of on its own. Rust is a very good example of this. Um, or rust, as I'm writing here. Rust would be a good example of this one because we have iron that's turning a red color. It's a new substance that's formed that gives it that red color. Just painting over the top of something would not exactly be a color change. And then the formation of a solid. That again would be we mix two things together, whether it's gas, solid, gas, and liquid, two liquids together, and we get some sort of solid being formed from that process. But again, you're going to want to know that a new substance is formed. These will give you an idea on whether or not a chemical change is happening, and then you can go and investigate on your own to make sure that it is a new substance formed. The big idea from this, and again, the goal of this video was to understand the difference between chemical and physical change and be able to identify them. These signs will help you to identify them, but the big idea is that in chemical changes, new substances are formed with new chemical and physical properties. So I hope that helps you to understand the difference between chemical and physical changes.